Okay, so we can start. Today we try to play with these two also, that are two Philips Hue lamp, and we use it as a, we can say, bench of proof trial to interact with smart devices. These lamps have a hub that is here. And you to interact with this lamp, you have to speak with this hub that provides a REST server. Similarly, if you want to speak with this, that is a quad sensor, temperature, humidity, movement, and light, you have to speak with the REST server provided by its controller. So the same mechanism that we see today is easily ported to other technologies, to other devices like this one. And let me reattach this. So today we want to create a REST client for the Hue bridge by using the Hue API that are available online. And we want to, here, on the website, there is all the API, also getting started guide, divided by lights, what you can do. You can turn on the lamp, turn off, change light, change luminosity, change brightness, and so on, change color, change saturation for each lamp separately. This bench, we will bring this bench to the La Dispe next week. So from next week up to the end of the course, you can access to this bench with the Philips Hue lamp. We have also another one of these in my office, and in the La Dispe there is a LED strip over a door. And also here there are two Raspberry Pi, one with also the Z-Wave domotic network, and a router that we will provide a Wi-Fi network with internet, a Wi-Fi network without the restriction of the eduroam and Polito, so more open. And we can also assign to you static IP address if your project need it. So you will see this bench in the future also. Right now, this has no internet access, so in a moment I will connect to this network and I lose internet. Now, then in this it will have internet access. So today we can try to create this REST client for lighting up all the lamp, in this case two. Here we have two lamps. Showing a color loop for 10 seconds, and then shutting down all the light. And then we don't have time, we will not have time, but I will show you another client for controlling the hue of a specific lamp, so the color, not the saturation, not the brightness, only the color of a lamp. And then the solution will be tonight on GitHub. Question is a little bit earlier. So I'll attach to the AmI course network to be in the same network of the Hue bridge. And I can open PyCharm. Maybe. Hello? Secure. I'm connected. Yes. The Hue bridge is at the address, this one. And if you open a browser to the address of the Hue bridge, you see this almost useless page. But it says that the Hue bridge is working and you are successfully connected to the bridge. So we are connected. Good. Then we can open PyCharm. So we need to develop a REST client. I we'll divide the project in two files. One to connect to a generic REST service, and another that uses this module to connect with this specific service that is the Hue bridge. Because if we need to connect to another device like this other one, we can reuse the same module to perform the same basic operation in REST, that is get, post, and whatever. So I can create a new project that I called in class Hue. Okay, so I create two Python files, one that I call REST, that will be our module, and the other that I can call Hue. That will be the script that we launch to interact effectively with this module. Let's start from this. This module needs to do one thing: send HTTP command. Possibly send get, post, put, delete, every command in one method, in one function. So we need to define, for example, a send function that will receive some parameter and will perform some operation. To interact with, to send HTTP request, you already used the requests module in the last lab that will allow you to perform get request, post request, and whatever. We will use that module here so that we can also check for exception, error, publish data, get data in JSON format, and so on. Given the fact that all these devices will nowadays provide you with JSON data. So it's immediate to have a response in a dictionary mapped from a JSON object. So we can, from request, import request. That is the requests. Requests is not included in the Python standard library, but you have to install separately. I already did last week. Otherwise, you need to do pip install requests. So in this send method, we can, in the Hue script, we would like to say something like send, I don't know, get to a URL, to a specific address with maybe a specific content type. Not in this way, but something like that. So we need some parameter here, maybe also with a specific body. Maybe not in a get, but in a post. We need also a body to be sent, also a content type. So for example, we can do a post to the Hue bridge address with a specific body to change the color of a lamp with the content type JSON, because we send a body in JSON format. So let's try to write this, this function. So we need, how many? 4 parameters here. We need a parameter method, a parameter that is URL, a parameter that is data that represent our body, and a parameter that is header. These 4 parameters: the HTTP method, the URL, the body of the content of the request, and the header that in our case represent a content type when this body is present. So we can also initialize this to a specific value. so that if we need to send a GET request, for example, we can also not specify all 4 parameters. So for example, we can say that method default to GET, the URL default to none. We cannot set the default URL. Data default to none, nobody, to the request, and header defaults to an empty dictionary. So first of all, we need to check if we use this function, we need to check if the URL exists or not. We cannot make a GET or a POST to a non-existent URL, to a non-URL. So if URL is not none, is not this one, is not the default, but also is not none because we don't pass anything, we can try to perform the request. The request with the S module has a request function that allows you to perform any type of HTTP request, GET, POST, and whatever. So we can import the request specifically. So from requests, import request. So we can use this here. And request as we have as 2 mandatory parameters that are the method and the URL. And then if we look at the documentation, now I don't have internet, as also other, 10 parameters, and 2 of them are data, our data here, and headers that we define like this. So method and URL are 2 mandatory parameters, the first 2, so we need to pass directly this here and this here. For the other, we need to specify the parameter in the request function. So we need to say that the data for the request function is equal to our data, and the headers in the request function is equal to our headers. So we can also maybe change this to be more clear, header. Okay. This if we run this, we call this send method, function. We perform in this case, a GET request. Well, now without this line to a none URL with none body with an empty header. This function gives you a variable that we can call a result. Result, we can initialize the result as none, so that we can check after if the method succeeded or not. And so here we get the result of our request. And if everything goes well, this result will have the response with the JSON object inside that we need to convert in a dictionary, for example, and pass to our other method. So if things doesn't go well, this method, this function, throw an exception that is called an error that is called request exception. That if we don't catch this exception, we don't consider this exception, it stops the program. in a bad way. So we need to write try to perform this operation, request, and if there is some problem, we can catch the exception, accept a request exception that we can put in a variable that we call e, and for example we can print on the screen e.reason, because the e object has inside various fields. One is the reason of the exception. Now this is underlined in red because we need to import from the requests module. So request exception. Okay. So in this moment we perform the request, we get the result. If we have any problem, we catch the problem, print the reason of our problem, and stop here. Then we can also check if the result is none. Maybe no exception, but the result is empty, is none. So if result is not, if result is not none, so if we have a result to process a response from our server, we can convert the response that is in JSON into a dictionary, a Python dictionary. That's the problem. Okay. So, for example, we can define a function here, a variable here, and we can call a response dictionary that we can initialize with nothing, empty. And then we can say that our response dictionary is equal to result, but the result is an object, and in this way we don't know if we know that this response is a JSON, but this object in this way doesn't know if inside it has a JSON, it has XML, it has text, it has something else. So we need to convert, to extract the JSON from the result, and the requests module has a JSON function that if it's a JSON, it extracts the JSON, convert it in a dictionary, and put here in our dictionary. And then, if a result is none, we do not perform anything. And then we can return our response dictionary. So let me reduce a little bit this. Okay. So what happened? Sorry, this is not needed. So to recap, this function gets 4 parameters, all with a default value that is get to a non object with a non body with an empty header. Check if the URL is not none. Initialize a result. Ask the server with a specific method, with a specific URL, with a specific data body, and with a specific header, something, if everything goes well, it take the JSON from that result and put it in a dictionary and return our dictionary, our Python dictionary, so that we can use it directly in our code. And this is the rest.py. Okay? Notice that one thing that maybe someone asked. I wrote here if URL is not none. I can also wrote for example, another example. If I wrote, let me write here, if result equal to none, or if result is none, what's the difference between these two? Here I use is not or is, it's the same, not the same, but the operation is the same. And in the other case I use equal, double equal.
Because none is an object.
Yes, I can also say what is the content? The first one is an equal on the content, check the content. So the content of a result must be equal to the content of a law, or to the content of none, that is none. In the second case, result, not only the content must be equal, but also the object in memory must be the same. This, the second line, include the first line. If it's true this, it's also true this. Vice versa is not valid. If it's equal the content, maybe or may not, the objects are equal. With none is practice, is equal to say equal, with none they are equivalent. Totally equivalent. It's preferred to do this in Python because it's more stronger as a equivalence. With other object, it's probably better, safer to use the equal. Okay? If you open, just to avoid questions for days. If you open a prompt and write Python, and you say that A is equal to 1 and B is equal to 1, and they print A equal B, you see true, obviously. If you write A is B, you expect it to see true or false. Another try. A equal, sorry, and then I'll explain you why true. In this case, equal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. A equal to 10 times 1, and B equal to plus 1. That are the same number. If I wrote A equal to B, it's true. If I wrote, I hope, is false, because it is the expected result. Because for a small integer, Python cached the result in one object. So this is why it's true. But the general rule is this. Two objects, also elementary objects, are maybe are true in content, are equal in content, but not in identity. Okay, just to avoid if with this is and then nothing work. Okay. Okay, back to here. So with none is correct to write is. If I wrote equal, the PyCharm said the comparison with none is better to be performed with is. So it also suggests to perform this operation this way. So now we have a function in a module that is called REST to send HTTP request to everything, to everyone that is able to response and process and response this. So let's open the Hue, because we want to speak with this and turn on the lamp in a color loop and so on. So we can, first of all, import REST. We created just to use it. Then we can create the main file, the main function. Well, main. Okay, def main. So we can write here. Do you remind the diff why we wrote this? To not execute this function during an import, yes. Only when we launch this script. Okay, pass. Okay, we need to initialize some variable. For example, the URL of this object. We can call base URL, and the URL of this object is 192.168.0.201. The Philips Hue, how it works, HTTP. It has a REST server. This REST server in the HTTP address of the server /lights contains all the information and allow you to perform any command upon all the lamp connected on the Hue bridge. And after lights/1, it allows you to connect and to get information from the lamp with ID number 1. These ID are automatically generated when you connect a new lamp to the bridge. Now we should have the lamp number 1, the lamp number 2, if I take the right one. And then we also have lamp number 4 and number 5. The number 3 was broken, so we remove from the bridge, but it does not cancel the ID inside. And the Hue bridge requires authentication to use soft authentication, to use its API. So the Hue bridge, this is the bridge version number 1, is not anymore available in stores. There is another version that is compatible with the Apple HomeKit. This is not compatible. As a default username, we can call a username, that is new developer. By factory is new developer. So we can use this username to ask information and perform operation on the bridge. And this is a username that is created by default on the bridge. If we want to create a personalized username, we cannot. But we should, if we have a look to the Hue documentation, that is developer, Philips Hue API. If we have a look at the documentation, we see in the getting started, for example, I told you this because maybe you need to create one of them. That, okay, this line that is not true. Currently, it's possible to create your own username in the bridge. Currently not, maybe last year. Last year it was possible, currently not. However, this option will be removed in future bridge version. So we need to use this other operation. We need to ask to create, if you want to use this operation, this authentication method, and not the new developer that is still working, you have to perform a post to the bridge address /API with this content, device type, and this is whatever you want. Typically, a name of the application and the name of the device. And then it replies you with a link button not pressed. You need to press the button and perform again the request. And it replies you with a number like this one, 1028, something like that. And you, for every communication, instead of using new developer in the URL, you need to add this long number in the URL. So now we don't do all these because it's a lot of pressing and sending requests that fails and so on. And we use new developer. You, for your project, you can use both of them as you will. This number can be created just one time. Okay, so I reattach to the AmI network. So here we have our base URL, our username. Then we can also define a lights URL. That is the base URL plus the API username and lights. Lights URL. We need here, just remember, we want to get all the lights, all the lamps, ID, and then perform a circle color change, and then wait 10 seconds, and then we want to turn all the lights off. This is the step that we want to perform. Okay. The lights URL is our base URL plus /API, I forgot this, plus our username, plus another slash, and a lights, and another slash. So HTTP, this address, /API, /new developer, /lights. This is the URL for getting all the lights, these two and the other two that are not here. So to get all the lamp ID, we need to send a get request to the lights URL. So we can use our method we just created. We need only to pass the URL, because the method of, this method is get, so is the one we needed. We need nobody, empty header, because it's a get request. So URL lights URL. REST.send. This REST.send give us a dictionary with all the lights. So here, if we try, maybe, we print these all the lights, we should obtain a JSON with all the light, hopefully. Okay, yes, we have a JSON in this amazing format. Maybe we can open here. New developer lights. Okay, it's fantastic. Maybe with Firefox. No, okay. No. Last trial. No. Okay. It's a JSON. It's not really readable. In this JSON, we have some generic information like, I don't know. We have the idea of a lamp that is 1 with its current state in another object. The Philips Hue define a lamp off with a on parameter set to false, and a lamp on with a on parameter set to true. They define this. With the brightness of this lamp, last time was set to this number. The hue is this one, was this one. The saturation, this one. No effect is applied to the lamp, that is one of these. And then there are some other information. The type of this lamp is an extended color light, because this is the lamp that we have now. It's not a simple, it's a colored lamp. That is a Hue lamp. Its manufacturer is Philips. The ID is this one, the software version. Then we have the second lamp that is here, that has the same, more or less the same property. Then we don't have a lamp number 3, but we have a lamp number 4 that is a light strip, that is the one in the lab, that is a LED strip. And then the lamp number 5, that is another type of lamp like this. And the manufacturer is Philips, because the Philips Hue uses the ZigBee protocol, the ZigBee lightning profile. So you can attach to the Hue bridge also lamps that are not Philips, but they are compliant with the ZigBee lighting profile. You can also use that. So the manufacturer is important for this. So this is the JSON. Wonderful. If we wrote here lights 1, we get the information only the lamp 1. It respects the rest standard, we can say, with the same identical information. If we wrote lights 3, we get the resource is not available because it's been deleted from the bridge. So we don't want to print this. We want to take we want to perform this circle color change on the lamp. So we need to iterate upon this lamp for lights in all the lights. okay? For each light, so this one, and so on. For each object in this array, in this dictionary, we want to call another URL because we need to turn on and perform the circle loop effect. That is an effect default in the Philips Hue. And the URL to call is lights URL, that is this one, plus light dot id, that is the lamp, plus state / state. Okay. Because we need to operate inside this state object. We need to change this, and we need to change this. And also the effect will change, it will become a color circle. Okay. So we need to operate on this object, so we need to access to these razors. I don't know if here we can, no. Okay. Not with a get. And we need to call this with a put, rest.put, rest.send, with, this time we need to specify the method, that is put. Then we need to specify the URL, that is the URL to call. And then it's a put, we need a body, that now I define here. And then we need a content header that I can define maybe here. Header equal content type. Application JSON. Because the body is a JSON object. It's correct, yes. So we need to pass also headers in this case. The header. And then the body is, we need to change the on property. We need to turn on the lamp. And we will also want to the body is a string, obviously. And we also want to specify the effect that is color loop. Yes. All this information are on the Philips Hue website for developer. All the APIs are reported there. So this put with this body is reported there. Again, I don't have the internet now, so I read here. And then, so we won't perform a circle change, then we want to wait 10 seconds. 20 seconds, maybe. 10 seconds for E in range 0, 10. Print 20 minus E, and then obviously we are not waiting nothing here, and then we need to wait 10 seconds. So we can use another module that is called time, that has a function that is sleep, that accepts a number of seconds. So for 10 times, we sleep 1 second. And we print the number as a countdown, we can also say time.sleep 10, Here we can also print the countdown. And then we need to turn off all the lamp. So we need to perform more or less the same operation here. So I copy this. So again, for lights, in all the lights, because I want to turn off everything, the URL to call is the same. For each light, I need to turn off each light separately. The body is not on true, but is on false. And the effect, we need to delete the effect. And then we can send a put to the same URL with this new body with the header that is, again, this one. With content type JSON, because this is, in our idea, a JSON file. It's better? No, sorry, it's wrong. This way. Okay. Because JSON wants double quotes, not single quotes. Here and here. Okay. So let's try. And it doesn't work. 20. Sorry. Why?
In the headers.
In the headers? No, on either it's okay. Should be okay. Maybe we can try to do this. Because either wants an object, so not a string. So we can try this way. And then we need to understand why. No. Okay. So let's check. Here it works. Then we need to do this. It should work. So the URL is correct. 201. API, new developer, lights 1, state. Yes. The body is on true effect color loop. Yes. No. The body is effect color loop, it's a string. Maybe this is a, let's try again. Okay. Because it's a JSON. So it changed color for 10 seconds, and then it turned off. If we wait more time, it continues to change color more time. This is a standard effect. The Philips Hue has a lot of effects. This is the color loop. If also the LED strip was connected, also that will perform the color loop. And then at 0, it stops. So, and this is the first virtual exercises that we want to perform. The first one was, let me take this again, better view, was to use the client for lighting up all the lamps for 10 seconds and then shutting down all the lights. and okay. And the other is was controlling the hue for a specific lamp connected to the bridge. So to perform the other exercise that I only show you right now, close project, Python Hue. I performed one step more. No, sorry, this is bullshit. Okay. So I used the same identical REST module as before, because we created just for this. And then I define a class that represents the Hue bridge. So computer engineer and maybe electronic. A class is, in programming language,
Set of methods and attributes.
yes, also I don't know, something else is a set of method attributes, but why? For objects, yes, but why? Why I can define a class and not, for example, another module with a get all lights function, a turn all off function, and another here function, and then maybe not this, but init, a plain init function, and I call this init function every time I need it. So I say, instead of class UBridge, I have a module UBridge, and I call ubridge.init, and that when I need it, and then ubridge.getAllLights, and so on.
It's a predefined model.
It's a predefined model, better, that contains properties and methods. Yes, it's a way, you can say it this way, it's a way to structure data, structure information in an object-oriented way. So we have a UBridge that is a class, and then in our code, this class contains, as you said, properties and methods that are functions. And in our code, I need to create an object that is UBridge, and this object automatically call this init method when I create it, and then I can also create several of these objects in the same script. And this is a difference with the import of a module, because the module, when I import the module, I take everything in that module, I put it in my script, and I have one module. I use that module every time. I cannot have separate instances of that I can work with in different way. So it's a small difference. It's for better structuring code in this way, in an object-oriented way. So a class is defined with this keyword. It collects functions that are called method, and also properties, variables, in this case not. A function in Python, if has a method that is called underscore underscore init underscore underscore, this method is called every time the object, the instance of the class is created. So when I here, when you write here this, UBridge with this parameter, this one parameter, is this method that is called. This is the constructor of the class. The constructor, what it did, it removed the latest slash if it's present, and then save this URL in a general variable that is available for every other call of these methods in this URL. And each instance with a URL has a separate variable with its URL. And then we also build the lights URL as before. So the self URL is the HTTP address /API/developer/likes, like before. And then I created four methods. One is getAllLights, that is identical as before. I call the send function of the REST module with the URL, this one, with headers application JSON that are not needed, really. Okay. With the URL, because we need to get a list of the lights, like as before. Then another function is to turn all off. That is, again, identical to before. We get all the lights, and for each light, we prepare the URL, and we prepare the body, and we send a put to the same identical URL as before, with the same identical body as before, and with content type application JSON. And then there is also a change state that if it receives a new state for a specific lamp, I want to turn on the lamp number 1, and I want to turn off the lamp number 2. So here I can write 1 and off, and then according to the on and the off, it prepares the right body, because remind that to turn a lamp off, you have to say on false. So I take the off and I set to false, and the on and set to true. Prepare the right body, and you need to send a put request to the same address that we already use for the color loop, with the body that is on when I want a lamp on, true when I want a lamp on, and false otherwise. And then there is another method, just to create some of them, to change the hue, not the saturation, not the brightness, only the hue of the lamp. And then the URL to call is the same as before. The body is similar. We need to turn on a lamp, even if it's on. And then we change the value hue with a number that we pass here in the method. And then we can send the request with a put method, with the same identical URL, with content type application, with this body that is this new body that we pass. Then I wrote a test that performed this operation, change the hue of one lamp. For example, lamp number 1. So I take here lamp number 1. The hue of this lamp is 49281. And I don't remember the color, but we changed this by value. Here. So to change this value, again, there is a if name equal main and call the main function. I create the bridge object by calling the class with this address, that is the address of the bridge again. We set the lamp ID to 1, because I want to operate on the lamp number 1 right here now. And then I ask insert a number between 0 and 255, or type exit to set the hue color between 0 and 255. If string, this is all things that you already know. Row input, get a string. If the string is exit, not is equal to exit, not is exit. Print goodbye and terminate the program. Otherwise, convert the value passed by command line in an integer, and compute the hue value, and prepare the body and print on the screen the final result, and then call the setHue method that is defined in the class that is the UAPI.py file. So call this method and put the number here. And then we stop the program. I needed to call also this compute Hue method because the Philips Hue use a complex a way to define the colors of a lamp according to X and Y coordinates on a plane in 2D. And there is a long list of mathematical operation how to convert a number in x, y, x-way coordinate and vice versa on the documentation. Long story short, the red is 6 is this number, the green color is the other number. I take the number, typically, I take the number I pass to the command line, I perform some operation with these two numbers, and I send the final result to the bridge that turn on the lamp. So if I pass 0, I obtain this number. So we should have a green light. Notice that we changed only the hues, not brightness, not saturation. So if the saturation is low and the brightness is low, the green will be not a lot of green. It's not strong. So let's try to start this Hue API test. So insert a number, I type 0. Okay. This is green with the saturation and the brightness that was previously set. So with this number as a saturation and brightness all to maximum. And this is the old Hue value. And now the Hue value should be this one. So let's try. Okay, the saturation has not changed, the brightness has not changed, the Hue value changed correctly. So we can also try again with a number between 0 and 23. And if we put 255, you have the red with the current saturation, the current brightness. Same things happens if we use lamp number 2. That is the other one, obviously. We put 0, go green, 255 is red, the same red, because they was in the same color loop. So they started from the same color and end in the same color. And if we put 100, it's violet, something like that, and so on. So this is an example. I can stop here. This is an example. I want to turn off this. This is an example on how to interact with a smart device. This is a Hue lamp. The same things happens more or less for every IoT device. They have or a bridge, here a gateway, and you need to send command, typically in REST form, according to the REST architecture in JSON, to the bridge, or they have a cloud that provide APIs, typically in REST, and you need to send the command and the request for that information. For example, in the bracelet, we have worked with a cloud. They have an API on the cloud, and you need from the bracelet speak with the phone will speak with the cloud, and you speak with the cloud. But this is a typical way of working. And other object like this, that is more like home automation, standard home automation, that is wireless. It has a server here on this Raspberry Pi. So it accepts JSON command in in JSON format, according to the REST architecture, and so on. And you can use the same, an example similar to this one, with the REST module, with creating a class, for example, or with a direct script like this to perform all the operation according to the module. Notice, finally, no, that the Philips Hue has a RESTful API described here. For example, for lights, for lights, we say that, okay, for a get to this address, we see all the lights with this example. That is what we did now to get new lights, newly added light to the bridge, for search for new light, and so on. There is a list of everything with all the requests, all the response with example and whatever. But it also have an SDK, official and not, official for iOS and Android Java, and also for example, Python, not official, but is here. I don't know, 7 different API that are not official and maybe not supported. So if there is an SDK, you can also use an SDK for your project, or you can use the API as you want. The SDK, if it's not official, may have the problem that maybe it's not, the API changes and the SDK not change. So maybe there is some problem of updating from this. But feel free to use the SDK when you want, or the API provided when you want. So I stop here. On Monday, there will not be lab because it's holiday in Italy. And we'll see you on Thursday. Have a good evening and night.